Hello. Can everyone hear me? I can't hear myself. Yeah? Everyone? Good? Cool. One more second. Hi, everyone. Welcome to the AI and ML Ops Theater. My name is Victoria Ivan, and I will be talking about. You can't hear you. You need to put those things on. Now, can everyone hear me? Yeah, you need the headphones. Cool. So yeah, I'll be talking about data and model monitoring using Python's function decorators. The first half of the talk is going to be covering the key concepts. So I'll be talking about what data and model monitoring is, what the different stages of machine learning pipelines are that you should be implementing these monitoring checks at, and then I will go into detail on various data and then model monitoring strategies. The second part of the talk is going to be a technical deep dive into how to implement these monitoring checks. So first I will be covering some fundamental concepts, then I will talk about, we will construct together a monitoring decorator. Can you hear me? And then at the very end, we will be looking at one example if implementing a data monitoring check using the recently constructed decorator. So I built a data and model pipeline, which you can find on that repo. I also added a QR code because apparently now QR codes are cool. So if you want to follow the coding parts, feel free to go on that repo, or afterwards if you want to refresh any of the bits, you'll find it there. Yeah, every single screenshot of the code is in that repo. So let's start. What is data and model monitoring, and why should you care about it? Data and model monitoring is one of the most crucial parts of building an automated and robust machine learning system. When you are getting your model ready for production, you don't want your data quality to deteriorate, and you don't want your model performance to get worse either. But these things will happen eventually because there are things that are outside of your control, environment changes, there might be some upstream changes, so things can go wrong. The only thing you can do is build a functionality into your code that flags if something is changing or if something is going wrong. So data and model monitoring are essentially of your code pieces throughout the pipeline that will ensure that whenever something changes, your data gets corrupted, your model performance starts getting worse, you will be notified as soon as possible. And there are other strategies to implement as well. If this validation check fails, I want the pipeline to stop. I don't want it to produce the results at all. So super important. This is kind of the first step to make sure that you can reduce the human from the loop, everything is automated, and your model is robust in production. So you might ask, okay, at what stages of the pipeline should I be thinking about these steps? Well, ideally, you should have something in place at every stage of your pipeline. So starting from the point where you're ingesting your data into your model pipeline, you should make sure that the data that you ingested is there and is correct. Throughout pre-processing, from the point when the data goes into your model, throughout getting the predictions, and then also if you're doing post-processing and you are getting your data ready for surfacing it for your stakeholders, you should have some checks in place there as well. Model monitoring, on the other hand, comes into the picture at the end after you've produced your results. So this is checking that the results, the predictions, the forecast from your model is as expected, correct, and will suit your stakeholder requirements. There are other types of checks that I'm not going to cover in detail, but I wanted to mention, which are more on the operational side. So if efficiency or the resources you consume are important, then you can have some operational metrics throughout your pipeline that will tell you how much resources you consumed on your cluster, or how long it took you to train a model, etc., etc. So these like operational metrics can be really useful if you care about resources. And now let's go into detail about the data monitoring checks. So the way I like to think about it is you have your input into the model, so these will be data monitoring checks, and then you have your output from the model that will be the model monitoring checks. And I like to break the data monitoring into two different parts as well. One is just checking the existence of your data. Does it exist, and is it the right data that you want it to have? So for example, I know it sounds really trivial, but maybe you should check whether your data has been ingested correctly into your pipeline, because sometimes something changes in the upstream system and then you are suddenly not actually reading in your data. Secondly, checking the schema of your tables is one of the most crucial parts, because sometimes the data type can change, the data format can change, or the column headers could change as well. And you don't want your data to be fed into your model and then break it at that point. You should be flagging it as early as possible. And last, probably more importantly as well, you should be checking the proportion of missing values in your newly ingested production data. So sometimes some models do have a tolerance to dealing with missing data, that's fine, but you should be aware of how much of your newly ingested data is not there in the first place. So that covered the existence check, what I'd like to say. But then even if your data looks fine and everything looks correct, you still can discover that some of it is not fit for your purpose. So these checks would be looking at the feature values and making sure that they are within the range that you would expect. So in this example, income cannot be negative. This definitely should be flagged. Because what happens if you feed this into the model, regression model, and then it just skews your results. But even if all those like logical steps are, again, fine, what you might see is that the distribution or the characteristics of your data shifts. And this is important because you've tuned your model, you chose some parameters on your training data, and say you've decided that you're going to revisit and retune in 3 months. But now what happens if your data starts changing sooner than that? These checks that look at the summary statistics, so standard deviation, distribution, quantiles, min-max ratio, they will tell you that, hold on, you should start retuning your model sooner because something has changed in the environment, whatever. So super important. And then lastly, if you have some categorical features, what I find useful is making sure that the frequency of each category hasn't changed drastically. So for example, if one of the categories just disappears from your production data, then you should go in and have a look at why that happens. Nothing is going to tell you, the code is not going to break, but you should think about, okay, what does this mean for my results? Now that we've covered the data monitoring aspect, let's talk about the model monitoring. Similarly to the previous checks, I would say once you get your predictions from your model, it can be quite important to make sure that the results are within an expected range. There is no extreme outliers, there's no extreme values that could interfere with your kind of business logic. Especially if you're doing post-processing. So imagine you have multiple meta models and you're trying to pivot everything into one table. Make sure that all the results, all the predictions are in the right shape and the right order. And now, once you've produced your forecast, so imagine you are working on a time series model, and you have to train and produce the model results every week, but you're forecasting for a year ahead. What I find quite interesting is you could look at, has the forecast from today changed drastically from the forecast that I produced last week? And if it has, what's the reason? You can go in and investigate. Without these like model monitoring drift checks, you wouldn't know that the model forecast has changed drastically. So again, looking at various deltas between the old forecast and the new forecast can be quite interesting. And lastly, but possibly, I said this a lot, this is super important, but this is maybe the most important, is model performance check. So this is where you have observed the actual values for the most recent data, and you are calculating some sort of error metrics on it. So imagine, again, you have a forecasting model, you know what happened last week, so that you are going to produce a model forecast for last week, calculate the metrics, and if this monitoring check passes, meaning the metrics is good enough for you, then the pipeline can go on and produce the result, train the model again and produce the results for the next week. If that check fails, You can decide to stop the code so it doesn't run. You can decide to bring up the model from last week and get the forecast from last week's model because you don't want to give corrupted forecast to your stakeholders. There are multiple ways to kind of react to these checks failing. Yeah, and now that we've covered the key concepts when it comes to what is data monitoring, what is model monitoring, there are loads of different ways to implement it. There are loads of libraries, tools out there that will help you actually implement these checks. I am going to talk about function decorators because they're efficient, they're simple, and they're cool, obviously. So let's go into it. And what are decorators? So a decorator is a design pattern that allows you to add functionality to an object, in this case to a function, without modifying its structure. I was trying to think about a similar analogy from the real world, and I was thinking maybe a microphone, because imagine you have a person talking at a normal voice. You don't want to ask the person to do anything differently, but you want them to be heard by a lot more people. So you give the microphone, which is the decorator in this case. The microphone does its job and makes the voice louder without the person needing to do anything differently. So that's what essentially a decorator does. It just extends the functionality of the original function. And it's commonly used in validation checks, logging, sending information, measuring execution time, so a lot of kind of operational things. So finally, we can start looking at the code. Before we actually build a decorator, there's 4 fundamental Python concepts that I'm going to cover so that it's easier for us to understand how a decorator is constructed. Step number 1, you can assign functions to variables. In this case, super simple. I have a function called myfunc that prints something, and if I assign this function to a variable called printName and call the variable printName with the argument parsed, it's going to execute the function that was assigned to it. Step number 2, you can define functions within other functions. Again, a simple example, you have a function called getSquare. You're parsing in a number as an argument. Within the function, we are defining another one that will just simply square a number that is parsed into it. So when you are at this point, when you are getting the result, so you're calling the inner function is visible for everything inside your outside function. So you get the results and then you can return that. So when you call getSquare, what it does is going to execute the inner function and return you the result. Also, these slides will be shared, so no need to take pictures, I think. Step number 3, you can pass functions as arguments to other functions. So you have a function called square that takes in an argument called number, returns the and then you have another function that takes in a function as an argument, and then inside the function I define that, okay, I want to square the number 5, and then if you return this function and then some variable, what happens is when you call square 5, at the point when you're calling it, it's going to execute the function that you are returning, and whatever that does is going to be returned as well. Step number 4, you can return functions from other functions as well. Similarly to the previous one, not very different. Again, we have a function called return something. Within, we are defining another one that returns the string 5. When I assign this return something function to a variable, which was rule number 1, and call it, so call getIt, it's going to be returning the string 5 because I am returning the inner function in the outside function. I hope that's clear. So now we've all seen all these 4 major concepts, and I think we are ready to construct our first decorator. So imagine you have a function that's called say5. All it does, it returns the string 5. Now, I don't want to change the structure of this function, but I want to add extra functionality that will make this string all uppercase letters. So what do I do? Sorry. So yeah, if you just call this function simply, it's going to return the string 5 as it is. Now we create a decorator. Every decorator takes in a function as an argument. So this will be important again for our monitoring decorator as well. Within the decorator, we are defining a wrapper function, which simply is just an inner function inside the outside one. And within, what I'm doing here, sorry, I'm assigning the function that I passed in to a variable. That was rule number 1. And then here we will call that function. So remember, the function is say5, so we will call that returns 5, and then adding the additional functionality, which is converting it into uppercase. And then if you return that, what's going to happen is it's going to print or it's going to return the version of the word or the string in uppercase letters. So in Python, the way you decorate a function is just simply using the @ symbol above the function. So that's what you see just above. One thing to note is that when you're writing this in Python, the decorator has to be defined first and then your function. So the order would be the other way around. Another really important thing to know is you might ask, I have a function, fair enough, but I have some arguments I want to pass into it. What does a decorator do? So the decorator works just as you would expect, accept arguments into the decorator as well. So if we look at this one, I just have a simple function that's called just words. It doesn't do anything because I want to illustrate that everything that will be happening is happening inside the decorator. So you have this function called just words, takes 2 arguments, and I'm decorating it with the decorator above. So that takes a function as an argument. Again, every decorator takes a function as an argument. And then in the wrapper function, you can take as many arguments as you want from the function itself. So those arguments will be passed in as word 1 and word 2. Then I'm just printing it so you can see what happens. When I call just words, it's the decorated function with 2 strings. The printed message is going to print out those 2 arguments. And then at the end, what happens is I'm just calling the function. This is calling this function with those arguments, but because it's not doing anything, nothing happens there. So if you wanted to use this in real life, that function would be doing the intended functionality. I'm saying the word function a lot. Anyway, yeah, so that's the key concept when it comes to passing arguments into decorators. And now finally, we can construct a monitoring decorator. I hope it's big enough. Yeah, cool. So we have a function that's called monitoring, and I'm passing in another checker function, which is going to be executing the logic, the business logic for the monitoring validation check. We'll come on to that in a bit. And I'm also passing in a message, which is simply just the name of your validation check. Within, I'm defining a decorator that again takes a function as an argument. The next line might be something new. So another thing is when you're building a decorator, you're passing in a function. The default in Python is that within the decorator, when you're debugging, the attributes and the information about the original function is lost, so it's not automatically copied. So Python has an inbuilt decorator called functools.wraps, which handles this. It's just for debugging. It makes sure that whatever metadata you had in the original function is copied into your decorator. So when you're debugging and you're in that place, you will be able to access all the information from your original function. So yeah, and then once you've added that decorator, then we can define the wrapper function. In that case, that's taking a data frame as an argument. So we will see the example implementation. It's because I defined this decorator, so it always takes in a data frame as an argument, and then when I call the function itself with that data frame, it's going to return a subset of the data frame that fails the validation checks. And on that subset, you can apply the additional functionality. Again, that's this one here. That's the function that you've defined in your monitoring function. And that is going to, again, return a subset of the previous data frame that will definitely be flagged as incorrect values, corrupt data, failed performance check, whatever. So again, this will be probably different for every single implementation. In this simple case, I just wanted to log the information. So if the corrupt subset is empty, meaning all the data, all the rows in my data are correct, I'm just going to log this check has passed, everything's fine. If there are any instances in the table that are if the return table has any instances, it means that some of the data is corrupted. So I'm going to log a message that says this validation check has failed and print the indices of the table where it has failed. So let's look at how to actually use this. Imagine that you have a data pipeline that simply reads in a CSV. So you ingest your data and you want to check you want to check if there are any missing values in this newly ingested data. So what you do, you create a function called check missing values. And this function, as it is, it just takes a data frame as an argument. It's going to be your original data and returns the instances where there are at least one or more missing values in your data frame. And remember, we've built this decorator earlier. You call the decorator with the @ symbol above your function, and this is where the additional functionality comes in place. So what happens is here you can define what logic you want to loop through your data frame or your object, and this is going to be returning the subset that has failed in your data. So for simplicity, I'm just doing lambda x for x. This is going to loop through my data frame and just return every single row. It's like super simple. If you wanted to do some like range checking, you could implement the function that returns only the values that are above a certain threshold, anything. And the message itself is just arbitrary message that says what kind of checks am I doing here. So when you call the check missing values function, or when your execution gets to that point, it's going to go into the decorator, and the decorator itself is going to execute your function that you've just defined. In our case, it's just going to return every single row as it is, every single row with a missing value. I'm also displaying it in the bottom right corner. So it's returning only the subset where at least one column is missing. In our case, that's the income column. And accordingly, it's going to log this message that says these indices have corrupt data because there is some missing values in it. You could ask, okay, fine, I was informed of like something has gone wrong. What do you do? And the answer is, it's up to you. I think there will be some validation checks where you will just want to inform that you just did it, and then you say that the team goes in and checks the logs every 5 days. There are some checks where you will want to stop the pipeline. You will not want to produce results with those corrupt data. In that case, you can stop it. As I said, you could implement a functionality where if the check fails, you will revert back to a previous model, a previously trained model, and produce the results using that. There are tools that can help you implement emailing alert, be sent to users or developers when something fails. Again, can be super useful. Or you can log warnings, info, anything that kind of makes sense from a business perspective. And that's it. Thanks very much. Are there any questions? I think there might be a mic. Anyway, yeah.
Who does the monitoring? Like, is it the user, or who does monitoring? If the users or data scientists?
Really good question. So who does the monitoring? There are obviously multiple answers to this. I think there are some checks where you want the data scientists to receive the monitoring warnings and flags. There are some cases where you want your users to be alerted saying, okay, I've produced this forecast for you, but be careful because there was something wrong with the data. But I would say normally is the development team who will go look at the information and then address the problem as it is. So if it's like data quality issues, you might have data engineers looking at it. If it's the model itself, you might have data scientists looking at it. But sometimes it can be useful for your users to be aware of something as well, especially if it's kind of a domain knowledge example. But yeah, good question. Any other questions? It's fine if not. Yeah, I hope that was useful. And you can find the repo on this link.